Installing new ductwork. Let's take a look at this picture for a second. This is a pretty decent looking HVAC system that was installed. Take a look at the ductwork itself. Look how nice and neat it looks. Do you see any sags? Do you see any sharp bends? Do you see anything that would possibly really restrict the airflow that is coming out of this particular system? In this picture here, you can also see that the ductwork has been sealed of any leaks, possible air leakage that may be occurring, because we don't want our ductwork to have leaks. We want to have all of the heat or air conditioning that our units are producing and deliver it to the space where we want it to go. We don't want that loss of heat and air conditioning. This is a pretty good representation of what you would want to see in a quality installation. Here they have used looks like flex duct, and it looks like some round duct. Also, we used some mastic and a lot of sealant in this particular installation. You can see how the ductwork is actually pretty well properly supported. It looks in maybe it could have been maybe a little bit more, or they probably maybe went a little more than what they should have, but it is definitely a very nice installation. So with sheet metal, it has a lot of advantages. It's very durable, and it is the most used duct material in many parts of the United States. Perhaps the greatest drawback, at least from an efficiency standpoint, is that ductwork can look good and be professionally installed, but it definitely can leak pretty badly. So to get around installation of ductwork that may be possibly leaking, you are going to seal all of your joints like you see in this picture. All of this white stuff, this stuff here, that is all duct sealant. All of the joints that the ductwork has is going to be sealed with that duct sealant. That is what's going to be used to prevent leaks or extreme leakage. The following points should therefore be kept in mind when working with sheet metal. You're going to want to design your duct systems according to the ACCA Manual D. Nowadays, there is many duct sizing programs that you can purchase and put onto your laptop and computer that will do all of the calculations for you to figure out how many CFMs go to each room, how big your ductwork needs to be, and your takeoffs and all of that stuff. But all of our ductwork that we have that is properly installed, and I'm saying that again, that is properly installed, will be installed in accordance with ACCA standards. We want to make sure that the duct sections are firmly connected with screws, slips, and drives, and make sure that they are sealed with mastic or duct sealant. We are also going to insulate all of our ducts that are outside the conditioned space. What do we mean by the outside of the conditioned space? If your ductwork is going to be installed in a basement, and that basement is not going to be conditioned in any way, that ductwork needs to be insulated. If the ductwork is going to be in the attic, and the attic is not going to be insulated in any way or used in any way. It needs to be insulated. If the ductwork is going to be in the conditioned space, say for example Home Depot or at an arena where the ductwork is physically exposed to the conditioned area, the ductwork does not need to be insulated. Okay, insulate all of your ductwork outside of that conditioned space with the exception of your return ducts in an unconditioned space. You want to resist the temptation of using the building joists as your ductwork. That is no longer allowed. Back in the day, we used to be able to take the joists in the floor and do what is called panning, just by simply taking a piece of sheet metal and covering that joist area and using the joist as ductwork. We are no longer allowed to do that, simply due to the fact that it is wood, and when moisture grows on wood, it creates mold. It can rot out the wood, ruin the floor joists, yada, so on and so forth. Therefore, it is no longer used. If you ever come into it and you see it in a home, it needs to be removed. So we have a couple different ways today to put in ductwork. We use fibrous glass ductwork, or fiberboard as we like to call it. This type of ductwork does have advantages as it comes already insulated, as you can kind of see in this picture here. There's the insulation. It already has a silver coating on the outside, which is meant to reflect the heat so that it doesn't get absorbed into the ductwork. It is suggested that when working with this type of material, it is to be used in an area where it is likely not to be damaged. I've seen it 100 times in homes where it's in the attic and it's actually crushed because people put stuff on top of it. Mind you, this is not very rigid ductwork. All it is literally fiberglass that is just shaped into ductwork, which is taped and stapled together. But it doesn't have the rigidity as metal ductwork would actually have. So your fiberglass, duct sections have to be carefully cut. They have to be taped. They have to be stapled. And if they are going to be exposed, they have to be somehow protected so that it doesn't start to collapse. However, this type of ductwork has been known over years, especially if it's been in the attic for years, to just simply deteriorate on its own and eventually just comes out anyway, and metal ductwork gets put in. Clean surfaces thoroughly before applying any sort of foil tape when you are dealing with fiberboard. You have to use special tape. Is generally used to attach the pieces together. Okay, we call that aluminum tape. Your ductboard will leak, perhaps immediately, but certainly with time, especially if that tape is not properly applied and or that ductboard is not properly cleaned before you put the tape on. To properly clean your fiberboard, you are simply just supposed to take like a mild soap and water solution and just gently wipe down the area where the tape is going to be adhered to. Wipe it down, dry it off, and then apply the tape. Over years, people don't do that anymore. Tape gets applied, it doesn't stick very well, and then over years, the ductboard just starts to leak and finally fall apart. Okay, we have to support the duct sections properly. This type of duct is not structurally or load-bearing type of material. It will collapse relatively easily. We also use what is called flexible ductwork, or flex for short. Okay, the greatest advantage of flexible duct is when it is installed properly, they do not leak between ends unless they get torn. This type of ductwork is very, very common. This is what that type of ductwork should look like when it is properly supported. Notice in this picture how straight that ductwork is. We do not want to have sags. We do not want to have any sort of sharp bends when we are dealing with flexible duct. That will create friction loss. It's going to slow down the air velocity traveling through that. When we are using ductwork and installing it, we want to try to keep it as straight as we possibly can with little bends. And if we have to put a bend in it, we want to keep it so that it's a gradual, a nice swoop, so that we don't have turbulence and we don't have air velocity issues in spaces. One way to improve that is you can actually purchase this nice little gadget that will sit right on and attach to your supply register, and that, by simply putting that in, can actually improve your flex duct efficiency anywhere between 10 to 40%. Why? Simply because the ductwork is no longer just sitting and just sagging down and having to kind of come up and then in. It's now a nice gradual swoop right into your supply and then out into the space. This is what we mean by improper duct support. We have excessive sag in there. As that air is coming out of this particular flex duct, it is hitting turbulence right here. It's slowing down because now it has to sag down. It's hitting this turn, and then it has to kind of climb back up again. This is improper. We do not want to see this type of installation. If it is, we can fix it. You can add another support, probably right around here or maybe right over here, just to kind of raise that flex duct up to kind of eliminate the that sag in there, which will help increase the velocity into the space or whatever this place is actually supplying to. Okay, when you are working with your flexible duct, you want to support it properly. Okay, it's just like every other piece of duct. Leaving too much space between your supports can result in your excessive sags, which will cause pressure drops in the ductwork, which is also going to slow down the airflow. Okay, we want to make sure that we cut it to the proper length before installing it. Okay, the serpentine bends that are inside there, excessive length, has the same effect as an excessive sag in the ductwork. You want to make sure that it is, when you are installing your flex duct, that you attach it and stretch it so that it is nice and tight. But you want to not have it too tight, because you do want to have a little bit of room in your connection for expansion and contraction of the temperatures in between there. You want it to be snug, but you don't want it to be so tight that it doesn't have room to breathe or be able to expand and contract. Okay? So make sure all of your ends are tight and sealed with tape or duct sealant to make sure that they are obviously leak-free. Okay, both conditions, your air and air exhaust duct, can suffer from common installation problems such as tight bends and crimping. The airflow at the duct is being reduced at installations with flexible ducts. So you have two of the most common offenders that are closely related to air velocity and airflow issues, is simply due to the fact is that the ductwork is not installed properly. We are having tight bends or crimping going on where that ductwork is being connected to and being connected to the actual area where the air is supposed to come into the space. Okay, bends in the duct should be gradual to prevent the loss of airflow due to turbulence created as the result of sudden change in direction. Okay, disruption of airflow at bends and open attic spaces usually occur where those 90-degree changes of direction are taking place. Okay, these sharply typed changes in direction and where there is only one support is typically located at the bend itself. Okay, other times there can occur when a straight connection or collar at the boot, okay, is defined as the transition between the duct inner core and the register, and is used in place of a 45 or a 90-degree collar connection built into the boot at the area such as terminations near the shallow attic space or at the end of a wall. So if we look at this particular image, we have a 10-inch round piece of flexible duct that is getting stretched out, and the register is in a tight corner. Okay, if we look at this tape measure, just because of the area of this register, that 10-inch flexible duct has now been crushed and crimped down to almost looks like about 6 inches in diameter. By doing so, we are cutting down greatly on the airflow and the velocity that is needed for that particular space. So once this home is actually finished and that air conditioning and heat gets turned on, you're going to have an issue with heating and cooling that space because the flexible duct is now crimped down. So to fix this particular type of issue, instead of running the flex duct like they do and making a connection here, they should have taken and put a 45 or a 90-degree elbow right up in here and made a connection and made the connection out here with the flexible duct, so that when that connection is made, it is still maintaining a 10-inch round all the way through and out into that supply. Another issue that you could run into is a very tight bends. I mean, look at this guy right here. That is a greatly reduced piece of flexible duct. That's not going to work so well. From that looks like that's probably a return. Air is getting sucked back into the air handler, and if we're not getting the proper amount of return air, you're not going to get the proper amount of supply air. They go hand in hand. Seeing stuff like this where flexible duct is crushed because of a drainage line or something like that, that's no good either. In that particular area, that flow is being reduced. That doesn't work very well. So when we are installing our ductwork, we want to have as little bends as possible. If we have to make bends, we want them to be nice and gradual. Okay, we don't want to extend greatly the connections. We want to try to keep them as short as possible, but we don't want to have massive changes in direction.